Hello everyone, welcome back to our channel. So today we are having the problem, that is problem of the day, Leetcode. The problem name is minimum time to repair cars. So let's quickly jump to the problem statement. So you all can refer the Leetcode website in order to see the complete problem statement. I will give you the crisp of the problem statement, basically the what the problem statement is saying in a simple manner. I will tell you. So in question we have multiple mechanics over there, each with a specific rank. Okay, and first of all, yeah, we have several mechanics, each with a specific rank. The rank determines how fast they can repair the cars. Okay, so a mechanic with rank R takes R into n square minutes, right, to repair n cars. Okay, there is a quantity of cars stated here, and the time taken to repair the car are and the time taken by mechanic to repair the car is basically R into n square. Okay, our goal is to find the minimum time required to repair all the given cars when all the mechanics works simultaneously. Okay, so the problem is basically is puzzled with situation based things, but here we have to be very clear. I will tell you through the examples. So constraint we are having, like one is less, rank length should be greater than equal to 1 and less than equal to 10 to the power 5, and a rank of I should be greater than equal to 1 and less than equal to 100. Similarly, we are having like number of cars should be greater than equal to 1 and less than equal to 10 to the power 6. Let's see the example to get more insights of the question. Like we have rank array, that is 4231, and cars is equals to 10. So basically 4231 are the rank of the mechanics. So mechanics with ranks 4231, and there are cars also. Total cars to repair is 10. Okay, so basically how much time each mechanic will take to repair a car? Let's see. This is the formula used here in order to analyze the number of minutes required by a mechanic to repair one car. So basically mechanic with rank 1 repair 4 cars, right? You can see. So formula will be like our rank 1, basically 1 into 4 into 4 is equals to 16 minutes. Similarly, we can assume it with the rank 2. Mechanic with rank 2 will repair 2 cars, that is 2 into 2 into 2 is equals to 8 minutes. Mechanic with rank 3 repairs 2 cars, 3 into 3 into 2 into 2 is equals to 12. You can assume it like this, and the total minimum time required, that is 16 minutes. Okay, so brute force approach, how we will do it, basically I will tell you like what we are doing is basically the idea is we have to try assigning the cars to mechanics in all possible ways and find the minimum time. Like you can see here, like we are first of all we are assigning 4 cars, then 2 cars, then 2 cars, again 2 cars. Basically it is hit and trial, basically brute force. If we think like we have to assign n cars to each mechanic. Okay, and after that we have to compute the time taken using R into n square, basically the formula given in question. Then we have to try different allocations as well and find the minimum maximum time. Basically this is hit and trial. Brute force is completely hit and trial. Time complexity for this approach will be like if we assign cars one by one, it will be in exponential. For example, like O of cars to the power rank dot length. This is the time complexity, which is too slow. And space complexity will be like we are not using any extra space, so it will be O of 1. Definitely we can say brute force is inefficient here, so we need to have an optimized approach, right? So optimized approach, if we think of it, we will be doing it by using the binary search. Okay, how we will do it? Just be with the till the last of the video. You will get the solution very easily. So optimized solution is basically with the help of binary search. So what we will do is basically instead of assigning the cars directly, we binary search on the possible minimum time required. Okay, so if we assume a maximum time t, we can check how many cars can be repaired within t, right? How many cars means like the n which is given. Okay, it should be within the range. If the mechanics can repair at least cars within t, we try a smaller t. Don't worry about the explanation part. I will tell you in much more detail in dry run as well. You will get the solution. Just be till the last of the video. So otherwise we will increase t. Okay, so basically I have broken down into 3 steps. Basically finally search on the time from 1, that is, to the worst case, that is the max rank into cars square. It will be the worst case. Okay, and for each mid time we will calculate how many cars can be repaired. Okay, accordingly we will adjust low and high, right? So if we dry run of the binary search approach, how we will do it? Basically this is the rank array and then number of cars. So we will define binary search range first. Initial range of the time, like low or high, and minimum possible time, that is the high min. Okay, so low will be 1 as I said, and high will be the minimum min of ranks into car square, right? So binary search will run between 1 and 100 in this case, because 10 is the number of cars, and if we are putting in the this formula, right, so we will get 100. After that we are having step 2, that is we have to use this complete binary search approach by taking out a mid between this low and high. So mid will be 50, right? After that we can check if we can repair 10 cars in less than equal to 50 minutes, right? So how we have to compute how many cars each mechanic can repair in less than equal to 50 minutes. It's quite obvious, like rank 4. First of all we have to calculate for rank 4, that is, it's easy. We have to take it by dividing over it, like root 50 by 4, that is root 12.5, and it will be 3 cars. Okay, again rank 2 is basically root 50 by 2, that is root 25, is equals to 5 cars. And similarly we will take for rank 3 and rank 1, and if we add total cars between this, like 3 plus 5 plus 4 plus 7, that is equal to 19. Okay, that is enough also. Okay, if we are able to make it to the value that is greater than equal to 10, so it we can say it is enough to repair, if it is enough for a mechanic to repair those cars in less than equal to 50 minutes. After that we will update the high value from 100 to 50, that is, the range will get reduced. Okay, range of time, basically I'm talking about range of time. Mid will be for 50 and 1 will be like 25 only. Now we will again repeat the same step, that is, if we can repair 10 cars in less than equal to 25 minutes, so we have to compute again, like this time rank 4 will be root 25 by 4, and root 6.25 is equals to 2. Okay, so basically this is, we have to calculate till all the 4 values, and total cars, if we can take 3 plus 2 plus 2 plus 5 is equals to 12, that is also enough basically. Okay, update, we have to update high, that is, earlier was 50, we have to update it to 25. Again we have to repeat this step. This time the mid will be 13. We have to check if we can repair 10 cars in less than equal to 13 minutes. So this time we have like root 13 by 4, that is 1, root 13 by 2, that is 2, root 13 by 3, that is also 2, and root 13 by 1, that is 3. So total cars this time is equals to 1 plus 2 plus 2 plus 3 is equals to 8. Since it is not enough, basically we can say, because it is less than the desired value, we are taking it over here. So we will update low this time to 14. Okay, why 14? Because this was the middle value and we have to increment it by 1. So mid this time will be 14 plus 25, that is 19. Okay, so how let's take the dry run for this low. We can, if we can repair 10 cars in less than 19 minutes, we will compute for each mechanic this time. So rank 4 will be like similar thing, and after that, after totaling it, we will get 11. That will be completely enough because 11 is less than equal to 19. Okay, update, we have to update 19. This time again we have to calculate mid and we have to check. Basically the process will get repeated. If we can repair 10 cars in less than 16 minutes, again this thing, and total cars will be 10. This time also, since we have the total cars the mechanic will repair is less than equal to the required value, so it is exactly enough for mechanic to repair these many cars. Okay, Again we have to update the high to 16. Middle we will get 15. So this time we have a task to check if we can repair 10 cars in less than 15 minutes. We have to compute for each mechanic. So basically total cars will be 1 plus 2 plus 2 plus 3 is equals to 8. So 8 is less than 10. So we can say that it is not enough for a mechanic to repair 10 cars in less than 15 minutes. He can only repair 8 cars in this time. Okay. So we have to update low this time. Again, after updating the low, binary search will get end. Low and high converge to 16 because low and high are at same position. So we will not repeat the process that we are following earlier, and we will return the answer as minimum time to repair all the cars will be 16 minutes. Now I will show you the code for this. It is not very complex. So we have to define the search range for the minimum time, like long low is equals to 1 for the low, and high is equals to, since that we can say the constraints are quite high, so we will be using long and one long into minimum element, that is ranks dot begin and ranks dot end into car square basically. And again we are storing the minimum possible time. We are taking long. Now we are doing the binary search on time. Basically why we have done high minus low by 2, so in order to avoid integer overflow. Basically we can do low plus high by 2 also, but since the constraints are quite high, so we are using this. Okay. Again we are having if mid time is enough to repair cars, so we have to update the answer. Can repair in time is a helper function which I will discuss in afterwards, just explaining afterwards. So answer is equals to mid. We are updating the answer over here, and high also. Basically we are trying for a smaller time, else we will increase the time limit, right? This is the main function over here, and this is the helper function which will be in private, like to check if we can repair cars in time minutes. Okay, so we are iterating over a loop, and we have to check if cars repaired by this mechanic in given time or not. Okay, this is the formula for it. We are using already I have told you all in the dry run, so it's not a very complex thing. After that we have to check like if the total cars is greater than equal to cars, we have to return true. No need to check further, simply return the total cars is greater than equal to cars. Basically this is a bool function, so simply we can return this. Okay, so this was the function and code, and let's see the time complexity for this code. So basically the binary search on time will take, it's always O of log min of rank into car square, that is O of log 10 to the power 10. And checking feasibility, like it was a helper function, you can see that is iterating. We are iterating over here, that is it will take O of n per iteration, linear. Again total complexity we have to like multiply it, that is O of n log minimum of rank into car square. So we can say since log 10 to the power 10 is equivalent to 30, the worst case time complexity is approximately O of n into 30, that is equivalent to O of n only. So making this approach very efficient, you all can use it, and it is a very unique question of binary search, basically binary search on time. So it's very good question to practice. If you guys understood the solution, please hit the like button and also share it with other students. Till then, thank you.